I want to show a demo of ClojureFX, which is a really nice GUI library and a good way of seeing how declarative UIs or declarative UI code and GUIs can work with functional programming. So let's get started with a line project. Okay, so we have our line project file. Let's add ClojureFX as a dependency. Then now we have the dependency, we can connect to the REPL. So first things first, how do we get a UI? Let's import the ClojureFX library. Everything that you see rendered on screen in ClojureFX is basically a map with a set format that the internals of ClojureFX expect and know how to render. So you're sort of declaratively stating what the UI is going to look like just with pure data. And in ClojureFX, they call these descriptions. So we'll create a new function for our root component. Ignore the parameter for now. So in JavaFX, you start with a stage. You can say always on top true. This is nice for development, so you don't have to keep alt-tabbing. So at this point, we have a scene within our main window. Now we want to add something to render inside that. Children of this VBox are going to be the visible elements of our UI. The VBox is just a spacing thing. We'll come back to the on action in a moment. So at this point we have a button in our UI and we have a label. The button has the text click me and the label doesn't have any text yet. So you can see how nicely the parts of the UI compose in code. You just have to declaratively state what you want. This is one of the reasons why I think this is underrated compared to OOP for doing GUIs. In general, I find declarative code is nicer to work with. Right, so we have our basic description. Let's actually make it do something. We will add some state. In this case, we'll just use an atom. And we're just going to have one value in there, count. We're just going to do a counter app. So how do we hook up our UI and our state? Well, to do that, you need to create a renderer. The renderer is basically just a function that takes a description of the UI, which we have here, and renders it. It handles all the internals of JavaFX for us. This wrap map desk is basically just saying that we want to render the root component. Now to actually display our UI, we're going to add a new function, show, take no arguments, and we'll just say mount the renderer. Calling this will kick off the rendering, so we just call it at the top level. Now we have enough code to actually display something. Let's compile it. Oops, I think that crashed because we have nil here. I forgot to come back to it. So we'll just add a, actually, maybe we can just do identity here. There we go. So we just see the button because the text is an empty string. Our mount renderer actually wraps the description with the state, so we technically can access it, but we haven't added the code to do that yet. The middleware is passing the state through to the top component. So we can access count from the state. And here, if we change this to str count, you'll see that the count didn't actually appear. This is because the way that this is working with the state, the UI refresh doesn't work properly. So we have to recompile everything. And now it displays. The click doesn't do anything yet, so because we're just using identity. So let's add something to update the state. This is basically saying update the state atom using this update function, and at the count key we'll call inc recompile. Now the clicks work. Since the renderer is a function, you can call it, and if you call it with no arguments, that will just re-render the UI again with the current state. So you can see that the state is persisted here. But we have an issue with the recompiling. We'd like it so that if we just update functions here and compile them, we could reflect that in the UI without having to close it and recompile everything again. So to do that, we need to use contexts. The first thing for context is to add cache. In fact, you can pass identity to the cache, but it will be less performant. So we might as well do it. We'll add the cache. Because I'm a Clojure noob, I don't actually know how to add dependencies without restarting the REPL. So I'll just do that. Okay, we're back in. Close that for now. So we're going to import the cache library. A context is basically what they describe it as a black box wrapper around the state. So the internals of the context don't necessarily matter, and I haven't bothered to look into them yet. So we'll just carry on and use it. And to do that, you update the state atom by creating a context. We pass it the state map, the shape of the UI, and the other argument we need is cache. The cache just makes the rendering more performant. Okay, so we technically have a context now. So to hook it up with the renderer, we have to update the middleware. Firstly, we want to wrap the components with the context. So this desk is referring to description, which is these declarative maps. The other thing with the renderer is you need to add some options to pass the context through the actual components you want to render. So we'll pass ops here. ClojureFX either renders keywords like this. These come from the internals of JavaFX and are mapped to the classes from JavaFX. You can also render functions, which we don't have yet, but this is how we can create our own components. And you can also render anything that implements the lifecycle protocol, but I've not tried that yet. I think it's useful for extending the ClojureFX library to do more complex behaviors. The other option is, so to interact with the context, you need to use declarative events for updating the state. So here we're going to add an event handler. So essentially, with an event handler, it allows you to remove the reliance of UI code and event handling code from a dependence on state itself. So if you look here, the component accesses state within its body. So this component is technically dependent on this specific instantiation of state, and we want to remove that. So the way we can remove the coupling of components and state is by adding the event handler. So first things first, we have to create a function which will handle the events. This is how we'll extend the event handler behavior. Events, when raised, are just maps. So it's another declarative behavior. And so this is saying when the event handler passes an event map to the handle function, we'll look at the event type key and modify our behavior based on that. We'll add a default handler so that we print if we get any event that we haven't implemented a behavior for. Now, to hook this up, we create an event handler, and we want to take the handle function and wrap it on either end. So if you think of it like a pipeline, we can do something beforehand, do the function, then do something after. In this case, we want to wrap coeffects. And coeffects are basically like a functional equivalent of dependency injection. The theory behind coeffects is more tied to like type systems and statically typed functional programming languages. So a lot of the kind of terminology is not necessarily as directly applicable to Clojure, but the idea is taken from another Clojure library, Reframe, which took its inspiration from some research, I think. Since the ClojureFX library was designed to be similar to Reframe, they just kept the terminology, I think. So coeffects are basically modify the arguments to the handler by adding something into them that we don't have access to where the event is created. So if we go back to the idea of we don't want state coupled to components, you can logically derive the idea that state is inaccessible from a component directly, which means that we need somewhere else to pass a state in so that we reduce that coupling. So this is where we get the state from. This is saying when a handler gets called, add to the map, which is its argument, the fx context key, and the value that the fx context key has is a dereferenced state. So unwrapping the atom here and passing it in. So the value of the context that the event handlers get is the context directly, so you don't have to dereference it every time. Now on the other side of the things, we can also wrap the result of an event handler, and these are called effects. Effects are basically a way of stating something is being changed in the outside world by calling this function. So that logically maps to the result of our event handler. And what this does is look for a key in the result value of a handler and do something with it. So on the other side, we're coupled to state in the event handler, and we're basically saying, look for a context key in the result of an event handler, and then update the state atom with the new value that's found in this context. So for each event handler, we have this kind of pipeline where we update the arguments, call the function, and then update the state with the result. So now we have all the event handling stuff wrapped up, we can replace this. And to do this, I will just create a new component to make the code a bit clearer. So we'll create a count component, and this will display our actual count. Notice how this is taking a context now. So the middleware, even though we won't have to, I'm not rendering it yet, but you'll see how when we render this, we don't have to pass context through. In fact, we can remove this since it's not being passed through like that anymore. So when we render here, we won't have to access context at this level because the middleware will pass it through at every level of the hierarchy. So the way the context works is they provide an API for you to access values from the context called subscriptions. And if you try and access the context without these, everything just breaks. So we'll add a subscription for count. This is just saying take the count value out of the context. And then return just a single label with the text current count and the value of the count. Now to render this, we can replace this, which was our label before. And here you can see an example of rendering a function component. So it's no longer a key, it's this direct function. And we don't have to pass anything additional here to get the state in. So now if we compile this, you can see how the UI is updated, but this won't work yet. We're still crashing because we're trying to update the state, but the state is now a context. So we get to see these declarative events in action. So when an event is called, so this onAction comes from ClojureFX itself, we want to raise or return an event map. And we know from before we're looking at event type, so we have to pass event type in our map. We're just going to call it update count. So now we need a corresponding handler to match this update count event. So we add a new method here. And you can see that we can access the context in the event handlers as well. That's coming from the effects. This maps to this. And now we need to map to the wrap effects. So we return a context key, and the value of the context is going to be swap context because you need to use the wrappers for context to update the value of context. This is like a parallel to swap, but works around the context API. We pass the context, and then do the same as before with update. So now, if we recompile this, we need to recompile this, and then call renderer with no arguments. The count updates like it did before, but you can see that we are decoupled from state here, and we just have this one point of plumbing code that handles it. And you'll also notice that I didn't have to recompile everything. I individually recompiled the functions that are changed, re-rendered, and the UI updated. And to make this clearer, I can even change this. And you see the display has changed, and I didn't have to close the window and recompile everything, which is nice. Now, anyone who's used Redux and React at this point might be thinking, well, how does this scale? Because usually if you have a single global state, it can get overcrowded, or you sort of lose the ability to have a coherent structure in your code. So ClojureFX also supports local state, It's a little bit more fiddly than something like React where you just have hooks. You could probably write some macros to make this nicer, but I'll just show you the simple example for now. I'll just update the UI a little bit to make it look nicer. I don't know if this region vgrow thing is idiomatic JavaFX, but it's just a little hack I picked up for replicating Flexbox justify between behavior. So it spaces the components out, so you have one on the top, one on the bottom, and then a gap in the middle that grows when you resize the window. Now to show the local state, we actually need to separate some functionality out. So instead of having a button directly here, we'll add a controls component and we'll wrap that in the local state. So if we replace this with the ClojureFX way of implementing local state, we change this to a fixed state function. So these ext things are extensions to ClojureFX, but in this case it's provided by the library directly. And this expects two keys, initial state and desk, which is a description of the UI. So this is going to be our function component for the controls. You'll see that we're passing strings here. This is just to make the UI code nicer above, and what we'll do is when the events get raised, we will convert them at that time, so that when you're typing in a box, it will stay as a string and we have to do fewer conversions. So what we're going to do is implement a controls component, which is going to be a text box where the user can input a value, a drop down for a different mathematical operation we can do, and then button, which does the same thing as before, but takes the values of the other two to update the count. So we'll add a controls component. So instead of taking context here, we take the state and the swap state. This is passed in from here. So implicitly, these pass state and swap state. Here you can see that when things are mapped to JavaFX classes, they use kebab case naming. So you can find like a text field. I wonder if it will show me the JavaFX one here. Maybe it's this thing. Oh yeah, JavaFX. So you can see how the mapping changes from this Pascal case to kebab case. Here you can see how we have these namespace properties. So this is only usable within the context of an HBox. So using this elsewhere won't work. But since this particularly corresponds only to HBox properties, then namespace like this. So this is basically, we have the same down here, VBox, vgrow. Yeah, so outside of this context, this doesn't make sense, but inside of VBox, you can use it. So here you can see with local state, we're directly coupled. The component is coupled to the state. So there's no declarative behavior here where we're subscribing. We just take the state straight from the arguments and we swap state here. Again, the mutations are directly coupled. So the text is the value of the local state, which comes from here, and swap state is passed in implicitly here. And that's how we update the local state. In ClojureFX, you get these on text changed or on property changed. It has this sort of format of on, XX changed. So basically, anytime a property in JavaFX is modifiable by the user, in this case the text, you get an extra event key, which you can map to either an event or in local state a function. In fact, well, you can do it with global state as well with a function like we had before at the start of the swap, but usually at global state level, we want to use declarative events. Here we're going to add a new function component, operation picker, which is going to be our drop down. Just keep the code nicer by separating it out. You'll see that in the case of local state, we're prop drilling here. So we have to manually pass state and swap state through because we don't have a middleware like context does that implicitly passes them through. So this shows a limitation of local state where you don't want too many levels of hierarchy because you'll end up creating too much boilerplate. But you have that trade-off of, does this logically belong at the top level, or should it live kind of encapsulated within a kind of hierarchy of the UI? The usual trade-offs. Okay, so here we add the button and we use the on action like before, where we're mapping to this update count event. So the button will be doing updates to the state at a global level, and it's got nothing to do with the local state. So let's implement the operation picker. As you can see here, since we're prop drilling, we take the same state and swap state that are passed through from here. Same as before, the state is coupled, so we're getting the operation from here out of the state, which is passed through here. Here is the event that will be raised when the value is changed in the combo box. So we're going to swap the local state and update operation with something. So basically take the event, the JavaFX event, get the value out of it. So since onAction for combo box raises a JavaFX event, not like a Clojure map or anything, we have to do something to get value out of it. Here are two kind of factory properties. So the combo box knows that it's going to have to render multiple children. So for each child it wants to render, how do you do that? Well, the cell factory tells ClojureFX, use this map to render each child. So we tell it that it's a list cell and the describe is a function. So because we're using a function to render this, it's describe instead of description, which is implied, or desc, which was, I don't know, we had desc somewhere. That implies more of a declarative. The description is like a noun, describe is a verb, and the function is a verb. So this cell has a kind of expected set of properties, and if you omit text, you'll get some very long errors. So we're just using the most simple format. Like you can use a graphical type, and then that will let you render kind of like other components like a button or something in there, where the default case is just set up to render text. So these are going to be our items in the dropdown, which are just our operations we want to support. So we'll just implement the combo event to value function. This takes a JavaFX event instance. So we're going to be doing Java interop here. If you've ever done any kind of HTML/JavaScript event handling stuff, this will look familiar, where we get the target, which will be the combo box, and we'll get the value out of the combo box directly. So the new value that you've changed it to is the value we'll get. So here, from the new combo box, will be passed to the local state. You can also work with JavaFX events in the global handlers. In that case, when you're using a declarative event style, they'll be passed through to the handler with the fx event key. So down here, you would do fx event and get the actual event passed through from ClojureFX. So the other thing to do is update this action, because currently it only supports add, since we've hard-coded inc down here. So we're going to look at the local state and modify the event map to have a bit more information to tell us how we can update the state in different ways down here. So we pull the value out of the local state, pass it to an int, and then pass that through to the handler with the key n. We're also going to pull the operation out of the state and implement a function here to take the string representation of an operation and return the function. So I'll just implement that quick. And you can see how we can just use the higher order functions to return the operators themselves, leading to quite readable, concise code. That's just a feature of Clojure, not ClojureFX. But if you're watching this, you probably know that anyway. And so the final thing we need to do is update the event handler so that it's doing more than just inc. So we will, here we want to subscribe to a value from the global context. In this case, we're going to get the current count out of the global context. Now we want to update the value. You'll see that these are both red, which is because we haven't destructured the op and the n from the arguments yet. So n and op come from here, and we can get them back out here. And because we used that extra function to convert a string to a function, we can call op directly here. At this point, it's one of those operator functions. So we take the current value of count and modify it with n, which comes from the text box and then gets passed. So we have next value, which takes the op, current, and the n from the user, and we're going to just associate count with the value of next value. Don't know what state we're in, so I'll just recompile everything. Here we have that. Add's still working, but just to make sure, yep, it seems to respond to that. Subtraction's working, division, always dodgy, but there you go. Okay, seems to work. So here we have a 2 and divide. So you can see that if I re-render now, these get reset. And adding up adds 1. So this is another trade-off with local state, that it doesn't persist the values across renders. But you know, you make that judgment call. Maybe, I mean, in this case, it kind of makes sense because the behavior so localized that it's easy to change, and it does reduce the cluttering here because it doesn't really make sense to have kind of operation in the top level state. Here we just clutter it up. So, you know, looking at this, immediately you can say there's a counter out, the only thing we have to track is the value, so it makes sense that that's the only thing in there. And these are more like implementation details. And that basically covers local state. So in summary, you know, you have this exe state, declare the state, and then render a subtree of UI, which access state, and you have to drill them, and it's localized and keeps this clean. Now, this looks pretty boring at this point, so maybe we could do something to make it look nicer. But the problem is, how do we do that? Well, let's say that I vaguely know that we can do some styling. How can we find out what styles are supported? Well, ClojureFX offers a dev tools as well. So let's give that a go. Close this for now. Back to the project file, we're going to add a new profile and a new dependency. So we'll add a dev profile. These are the ClojureFX dev tools. Now, because I'm a noob, I'm going to restart the REPL because I don't know how to install them without restarting it. We'll add the dev profile here. We get this back, but we don't need it. So in the REPL, if we do require ClojureFX.dev, and then I think it's ClojureFX.dev/help UI. This pulls up the DevTools window. So let's say we want to style our label. Find label in the list here, and we're going to go down to style. Style. Okay, so looking at this, they give an example. So we know roughly that for the style property, which is passed to our component, we want to do this -fx blah. So that's the syntax. How do we find out what properties are supported? Well, if you open the Java doc here, and you have a little route around looking for style. I think style here, and then because I've done this before, I know if you go to set style, then you get CSS reference guide here. Now we look through the controls and we say we want style label. So let's find the label. Okay, FX font, that sounds promising. Let's click the font. And here you can see what font styles are supported. So, you know, let's say we want to change size and weight. So down here, these are the actual JavaFX classes that we'll want to use. So kind of tying these two ideas together, this and this, let's just say we want to do font weight and font size. So if we come back to here and look for our count, let's just separate out the labels so that we can style just the number itself more easily. Okay, so we've separated out the current count and the count value itself into a VBox, and here we have our style map. So we're going to add our new styles that we want to add, so FX. And you'll see we actually get a drop down of things that are supported. But it doesn't always work, because it doesn't tell you font weight is supported. But we know from the docs that it is. So if we update this, re-render, now we can see that our value has taken on that style, which looks better. There is a ClojureFX library called CSS, where you can write your own style sheets using these classes. But I'm going to skip that for now, because to make life easier, we can use a pre-built theme library. And a nice one I know is called AtlantaFX. So how do we get AtlantaFX? Well, back to the dependencies, we can add it here. Okay, restart. Keep the same profile. Okay, move this out of the way. Okay, because AtlantaFX is a Java library, we need to use import instead of require. Here we've imported from AtlantaFX, and we need this to actually set the style sheet that AtlantaFX provides. So down here in our show function, just before we mount the render and display the UI, we want to just apply the style sheet given from AtlantaFX. So instantiate the Cupertino Dark instance and apply the style sheet for JavaFX. Because we're calling this outside of the renderer, we just need to recompile it, I think. Now you can see that we have their style sheet, which looks nicer. if you look at the ClojureFX page, you can see how they've got nice styles for buttons based on different actions and stuff, but I'll leave that for now. It's just more of an example of how to get the style sheet hooked up, and that should save you a bunch of work, making your application look nicer. Okay, so I talked a lot about decoupling and referred to dependency injection and so on. And in OOP code, dependency injection lets you test things more, well, it's not just for that, but one of the side effects of that is that you can test things more nicely. And a byproduct of less coupling is nicer testing. So how do we actually test the UI? So Line gives you a test file by default. So let's make some changes here. We import the ClojureFX API here because we're going to need to write some wrapper functions for dealing with context or creating context. So firstly, since our application relies on context for state, we're going to create a test context. As I mentioned before, you can pass identity as a cache function. Since we don't need any caching behavior in the test, we can just use identity here. And we're going to pass in an n, and this allows us to instantiate the context with any value of count. Let's start off by adding a test for the count component. Okay, so we're going to create a test for checking that the components render the value correctly. So let's create a context. We're instantiating the context with the value 0 for the count, and this means that we would expect to see 0 in the UI for the count value. So let's create the component now. Since the component is just a function that takes a context, we can create it here. But we have to manually hook up the context to the count component. This is what the middleware does for you in the actual UI code. Now we just say, look in the count component body and see if the value is what we expect. So since component just returns a map, we can use getIn to say, look through children, first child, or not first child, but child at index 1, and then the text value of that. So if we look at the structure of the count component here, this is what it returns, just a map. So the top level keys are children, we look at index 1, and then the text value here, where we actually render the count. So we would expect that to be 0. Let's compile this, and if you right click, Canva gives you a big menu, and you can see here are the commands for running tests. So we could just say run the current test, and it passes. Just to double check this is correct, let's try and make it fail. So we recompile the test, and then I think it's CT, and we can see it fails with 0 and 1, although these are the wrong way around, which has confused me. So if we bring it back, recompile, rerun, it works. That's strange. Expected 0. Really, you would think, oh, you know what, it's because I've done this the wrong way around. You can tell how much of a Clojure noob I am. I've never really used the testing library first. So there we go. Change this to 1. Compile, run, expected 1, actual 0. Okay, so that is a convention thing, I guess. Right, so that works. So the default case of just showing the UI in the first place looks good. Right, let's test some events because they will also decouple from state. So how do we run events through the test? We'll make a helper function to do this. So this is us creating our event map, which is the same as what we create here. Because this is namespaced, we have to manually construct it here. We're passing in n and op, which will manually pass through in the actual test. So take the event map, pass it into the handle function, and then just get the context because we expect that it will return a map with a context value. This is what the plumbing and middleware of the UI code does for you. So now let's call this and see what it does. So we're going to create a context here, a new context, and just pass it directly to the update. And the operation is plus and the value is 10. So we start with a 0. We're going to expect that this adding 10 to 0 will give us 10. So we can compare the resulting count. So take context from the result of the update, subscribe to count. In the test code, we still have to do these subscriptions to get values out of the context. Now we can just compare it. And we just double check. So compile this, and then run this test. That passes. Let's see. Let's invalidate it and double check. Okay, expected 10, actual 15. So that seems to be working correctly. Cool. We could also check that it worked with different operations. So if I change this to 1, actually let's change it to 2 times it by 8, would expect this to be 16. So yep, that seems to line up. And so make it pass. Okay, all good. And you can see how you can expand this. Yeah, you know, we could make it a test to test each one of these, but you get the idea. One last thing to do is see how they combine. So does the UI update after events have been called? So let's add another test down here. Start off with a context where the count is 0. We will render the count component with the initial value. So you would expect this to have count of 0. Create a new context, which is the result of calling the update event with a +10. And then render the count component again with the new context that we got from after the event. So in this case, we want to do something similar to this, where we'd expect the value is 0 before, and the value will be 10 after. The path stays the same here. So if we compile this, run this, you can see that they all passed. And once again, if you want to change some things around, let's say that we start off with 2 and we want to subtract 5, compile, test. So before the event, because we had 0 before, it's actually showing 2, and then subtracting 5 from 2 gives you -3, so we update these. So this will be 2, this will be -3. There we go, test good. So it seems like rendering our count component after events have been run works correctly. And this exposes some of the data flow that the middleware handles for you, where we have contexts and we render, and then it does some internals to like advance the state in response to events, and then re-renders by just calling the functions again. But you can see how we actually get some quite nice code for testing the UI. Okay, so testing seems good. There's one last thing I'd want to talk about really, and that's custom events. So really we've been self-contained in updating the state of our UI. How do we interact with the outside world a bit better? So let's say every time the user presses the eval button, we want to save a log of the current value and what operation was taken to get there. For this, we're going to need to modify the global state. This is a bit of a hack really, but let's just say initial is true. So basically, because it gets called in response to the user doing an action, we want to log the initial value as well. So let's say this is basically saying the first time the user presses the button, if the initial is true, we also log the initial value. And every subsequent call will only log the new value, but we need to do the initial one for the first call. So let's create a custom effect handler. So here in the effects, we have this update state effect, but this isn't the only thing you can have. Since the handlers return maps, you can have multiple keys that do different things. So let's say you wanted to add a file system effect that does the logging. Well, what we can do is we can say wrap effects should look for fs in the return value. So the map that the handlers return, look in that for an fs key. And if you find an fs key, let's call fs effect, which is a custom handler. So how do we do a custom handler? Well, we create a function. So every time the fs effect gets called, these are the keys we expect to find. The second argument here is dispatch, which we won't use, but it's how you can kind of chain effects. So you could say an fs gets raised and say the file save failed or something, then you might dispatch something back to the UI, update in the context an error value, and then that will get rendered just to let the user know that the thing failed. But we don't care about that for a simple demo. So what does this fs effect do? So back to what I was saying before, when we're at initial, we want to append the file with the value 0. We'll implement append log in a moment. And then for the rest of the times, what do? Well, we want to write a new line to the file with the values from the event. So take the values from the event and append a new line to the log of this format. Right, so we need to tweak the event that gets raised here a little bit. Because we're going to need the string value for the log, we'll modify this. So don't call this show op to function yet. Pass the string operation to the event directly. Now, in update count, which is the event that gets raised by clicking the button, we need to check some extra stuff. So we need initial for the FS effect, for the subscribe to the initial key in the context. Since this is a string now, we need to create a function version of it here using the same function as before. Call the function here. The new value of context is also going to need to set initial to false, because anytime this is called, it's no longer the initial call. And we're also going to return the FS key so that this will call the FS effect. So how do we do that? What does it expect? Initial value NOP. So the subscribed value from initial here, which is going to be true for the first call. And so here, because we've changed this around a bit, OP is a string here, so we pass the string to the FS effect and we call the function version here in the handler itself. So now the correct value should be passed to the FS effect. There's just one more thing to implement, and that's the append log function. So let's just create a little function here. So write a new line to the values.log file with the content from here. Let's try it out. Recompile everything. And we've pressed it a couple of times. Let's see, do we have a values log file? Here we do. So you can see we've added, let's change the operator and the operand and see if it works. Yep, it seems to be working correctly. So each time we press this button, which is here, raise an update event count. Update event count has two effects. One is updating the context with the new values, and the other effect is updating the file system by this effect, which writes append log. That's how it writes the file. Let's just test it with the other ones. And divide by 2. There we go. That seems to work correctly. And that's pretty much the overview of ClojureFX I wanted to give. The general building blocks of how to make declarative UIs. So if we just go over the code, when people say that OOP is a sort of like a killer tool for doing GUI work, I would say that declarative actually can be quite nice too. If you're not familiar with Clojure code, maybe this looks horrible, but once you understand the kind of structure, everything's just spelled out very simply. And the hierarchy is obvious just from looking at the code. We have top level with children, function components, decoupled state, which is easy to test, effects. It pretty much has everything you could need, and there's very little boilerplate. So yeah, I think give it a try. Thanks for watching.